Here are your solutions to 7-2. These are the letter problems. I think the easiest way to do this is to turn the answers on and then talk about where each individual answer came from like we did before. First of all, we can show that angles A and M are congruent. We have angle A congruent to M because we should have noticed right away that we could reflect this over this line here and we would have congruent angles here and here. So that's where A and M came from. So check that one on yours. We also have B and N. Let's do this in a different color. B and N. So we have B and N here. So we would put a single arc, and it doesn't matter how many arcs you have as long as you have the same number of arcs for M as you do A. And actually, I don't really think that they made it clear that you need to put these hash marks and arcs in here. If you have the congruence statements, that's just fine. Don't worry about putting the marks in here. If the marks help you, by all means do that, but you do not need to do it for your answer. And then we also have in green, we have K and O, so these two are congruent. Lastly, we have S and P, so S and P are congruent. And now let's do the line segments. We have line segment AB and MN, so here's AB and here's MN. Then we also have BK and NO, so here's BK and NO. Next we have KS and OP, so that's down here and down here, KS and OP. And then lastly we have SA and PM. We have SA and PM. So check and make sure you had all 8 of those statements. Remember, when it comes to a line segment like PM, you can call it line segment PM or you could call it line segment MP. It is the same answer. That doesn't really matter there. But in a congruent statement of triangle to triangle, then order is very important, as we'll learn in a little while. We'll do the same thing for problem B here. I'm not going to go through every single one of these, but I'll go through at least some of them for you. For example, we have angle W and K. If we reflected it over the x-axis, we would have points here and here, and then L would transfer up to here, and K would move up to here. And then from that point, we need to move from here all the way over to here. So we can take a look at this. I'm going to do this part of it first, since we're already having to look at this in order to figure out where these letters match up. So the thing we ought to do is make sure we call this M prime, L prime. This up here would be K prime. And then lastly, this would be N prime. So then once we have that, we have the reflection over the x-axis, and then from this point over to this point here, following like this, we moved 1, 2, 3, 4, 5 units to the right. So that's our translation. I'm sorry, our translation and our reflection, or in other words, our series of transformations. Be careful about those two words. And then lastly, let's go through these statements here. We'll do just a couple of these. WK would be angle W, and angle K would be this angle here and this angle here. Now notice, remember, I should have left that on there. We had this roughly like this. I'm going to draw it real quickly here. Had it like this, and this is K up here. So that's why it's probably a good idea for you to draw it up here, and then you see that W and K match up, X and L match up right here. This would be L. And we also have Y and M and Z and N. And then it's the same thing here because we have, this was L prime and K prime. So we have KL and WX is right here. So I'm going to let you take a look at those. Make sure you check every single one of these and really make sure you understand what you're doing here. And remember, a really important step, I think, would be to do the reflection of this and write in your letters here, your M prime, your N prime, etc. Doesn't matter if you shift it over here because obviously then things are going to get really crowded, but you can look at this and plainly see. We'll change the color here for one of them. You can plainly see that you have MN here would be congruent to YZ. So if you look over here, you've got MN congruent to YZ. It's really easy to see if you actually do the reflection. Okay, in letter C, they ask us, in the figure shown above, okay, the length of CE is 2 feet. So I would draw that here. We go CE, and that's 2 feet. Well, if we go up to our original statement here, CE is congruent to FG. This statement tells us that, as well as looking at the diagram here tells us that. So it asks us, what is the length of FG? Well, the length of FG, that's part of our congruent statement. Therefore, they're the same length. Therefore, our answer is 2 feet. Please press pause and do guided practice. Okay, let's take a look at problem number 1. Triangle RST is congruent to triangle UVW. Write congruent statements comparing the corresponding parts. So we could look over here and put the hash marks in and whatnot, but I don't think you really need to, because remember I told you that you can say that R is congruent to U just by position. So there's the R to the U. You can also say that S is congruent to V. Right, there's S congruent to V. And lastly, you can also say that T is congruent to W. These all, of course, are angles. So that's your first 3 statements there. Secondly, you can also say that RS, the first 2 letters, that's a line segment, would be congruent to the first 2 letters over here. That would be UV. There's that statement. Secondly, you could say that ST, the last 2 letters, are congruent to VW. So you have that statement there. And then lastly, you could use the first and the last, R and T, that's right here, is congruent to U and UW, the line segment. So there's your 6 statements right there. And then the other thing they ask is determine which transformations map one onto the other. And here's one possible answer. Remember, you could do this in more than one way, and you might do it in a different order, but this is one possible answer. If you translate RST up 4 units and then 2 units right, okay, so if you went up, this is RST, so if you went up 4 units and then 2 units right, and then reflect it over the y-axis, and coincides with UVW. Some of you might reflect it first, so you have it over here, and then translate it by going up and left. Now let's take a look at problem number 2. In the table design shown in example 3, suppose BE is 18 inches. What is DG? So let's move up there. So BE, remember, is 8 inches. BE is 8 inches. So they want BE, I think it said actually 18 inches, and they want GD. So now that we've looked at it, we can see that whatever they gave us for the one, we're going to have for the other, because remember, BE, which is first and last, and they're asking us DG, which is also first and last. So we know that the 2 are congruent. We can go back down to where we were and recognize that because BE is 18 inches, DG is also 18 inches. And lastly, question number 3. How can the coordinate plane help you determine that corresponding sides are congruent? And a sample answer would be you can find the lengths of the corresponding sides by using the coordinates of the vertices and the distance formula. In other words, very similar to what you did in problem number 4 yesterday, where you had the 3, 4, and 5 right triangle, and you had that on a coordinate plane where you could count up that this was 3 long, this was 4 long, and once you knew this, you could use the Pythagorean theorem, or the fact that you remember that there's a thing called a 3, 4, 5 right triangle. So if this is 3 and this is 4 and this is a right angle, this one had to be 5. But remember, you can also use the distance formula. Please do independent practice.